right, and welcome back. We're going to continue talking about those double integrals and doing those double integrals over regions that are not rectangular. And so it turns out that we're going to focus on a set of special domains. And so you can see that there's a definition here that we're going to discuss as elementary regions, and these are one of three things, and so this is going to allow us to expand kind of our working knowledge with double integrals. The first elementary region is called type 1, and this is an x-simple region, and so you can look at the definition and say, okay, well, x is bounded between two constants while y is bounded between two continuous functions of x on our interval. Okay, so what we would see graphically is something maybe like, okay, so we know x is bounded between two values, say a and b, and y has something funky going on to it, and we're going to call this delta x, and then in the bottom one is going to be gamma of x. Okay, so that's kind of what we would see in a type 1 region, is very clear boundaries for x between two constants, and then the y boundaries are between two continuous functions. Similarly, in a type 2 region, this time now y is bounded between two constants, d and c, and then x is varying somehow according to a continuous function of y. So we have between alpha y and beta y. Okay, and then type 3 is just both type 1 and 2. Okay, so then you notice I have simple underlined. Well, why do we care if it's simple? Okay, the idea is that if we look at these regions and we're taking slices, okay, I want you to imagine taking slices through each of these regions. Let's do some horizontally in the first one. Okay, if we look at the first one, well, the slices are kind of okay in the middle, but then as I approach the boundaries, at least, this interval, or the slice, would have to be cut up into three different pieces, right? So we really want these slices to be nice intervals. Okay. And so we don't want any holes or gaps. Okay. And we also want the slices to change continuously. And this last part is because of those boundary continuous functions. Okay, so instead of doing horizontal slices in the first one, I can do vertical slices, and you notice that the vertical slices are much nicer. They don't have any gaps. Okay, and so if I do that same procedure in the next one, okay, do horizontal slices, so the y slices are actually pretty nice, but then the x slices, well, not so nice, right? Because I'll have things going through the boundaries. Okay, so that's kind of why we have the simple criterion in there. And now this next one, I want you to pause the video and identify each one of these as type 1, 2, both, which really is type 3, or neither. Okay, and be very careful with your definitions. Okay, the first two are actually going to be both. So this is going to be type 3. So if I were to do slices either horizontally or vertically in this first one, I would have very nice continuous functions that I would be bounded between. And same thing on this one. Okay, so I can do horizontal slices, I can do vertical slices, and they'll be between nice continuous functions. This next one, you notice that if you take vertical slices, that's not so nice, but if you do horizontal slices, those are pretty nice, so that makes it a type 2 region. And then the next one is probably one that has tripped up a lot of you. This is actually going to be neither. The reason being is precisely this, and I'll make my highlighter a little bigger, precisely this segment, or this kind of edge here. Okay, so if we were to take slices, right? I have nice slices here, 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 and then whoa-bam, after this corner it changes, so there's a discontinuity. Okay, and similarly, if I do slices this way and then after, whoa, jump, right? So I get a discontinuous function. Okay, my condition on simple was that I had to have continuous functions. Okay. This next one, again, probably one that tripped you up. This is going to be a type 1 because what ends up happening is as we move through, okay, so our x slices end up being okay, but if we look at y slices, we're going to see, oops, I want a different color. Let's back that up. Let's do blue. If I do y slices, right here I have something that's changing continuously, and then there's a jump. Okay, so that is going to produce another discontinuity in the y functions. This next one is a type 1, and then we have type 2, and finally we have neither. Okay, and so that's going to wrap up this video, and we'll use this in the next video and discuss integration further.